In this video, we are going to study these topics. We are going to study loops. There are different kinds of loops offered by the C language: for loop, while loop, and do while loop. And we are going to study the jump statements which allow you to jump from one program segment to another program segment. So we are going to do these topics today. Before jumping onto loops, let us look at this program. It says that it's a multiplication table printer, and it is asking for the number of which the multiplication table is to be printed. Let's enter the number 5, and it does print the multiplication table. We are getting the multiplication table correctly: 5, 10, 15, 20, up to 10. So let us look at what the program is. So this is a program for that output which we have just seen. It is nothing but a multiplication table printing program. As usual, we have the main function stdio.h include. Then what we have done is we are asking for the number and saving that number into this num variable, which is an integer, and we are printing each time the value of the table. So printf %d means the integer, and the operation is num into 1. The second time the printf is printed, we multiply the number by 2. So this way we are printing a multiplication table. Now this time we had to print the multiplication table up to 10 numbers only. But what if the numbers could have been greater than 20 or greater than 30? So you would have to write 30 printfs here, and a lot of printfs here. Therefore the problem that arises here is that you have too many printfs. Or you can say too many statements to be written or to be executed. So this is one of the problems we face. And as we have to write too many statements and it depends upon the input by the user, or it depends upon how many times you have to print the multiplication line. Is it up to 10 times, or is it up to 20 times, or more? And this makes the program very lengthy. So we have a lengthy program, and it is of course not a flexible program, right? If the user says that he wants to print the table up to 20, so he cannot do that, right? So the program is not flexible. Let us consider this program segment and try to determine how we can reduce the number of statements, or how we can reduce the complexity of this program. So what you can see is everything is constant. Rest one thing: these numbers 1, 2, 3 and so on are changing, right? The only thing which is variable are these numbers. Other is constant. We have the same thing. So what we can do is we can put this changing, varying constant into one variable. Let's name that I, and write a single statement. Write a single statement like this. We can write printf, and then as it is written %d \n, and then we can print num into I. Now let us understand the concept of loops now. How looping can help make this statement to make a successful multiplication program, or any successful looping program. Let's look at loops now. So looping is nothing but it is the repeated execution of statements based on a condition. So let's say you have statements. These are the statements, the way they are executed in a C program. You have statement 1, 2, 3 and 4. Let's say you have to repeat statements 2, 3 and 4. Let's say you have to repeat them 2, 3 and 4 again and again. You have to again and again execute them, but based on a condition. Only if the condition is true, these statements will be executed again and again. There is a circle here. Look, the control goes back to the condition, checks if it's true, again executes and goes back again. But once the condition is false, you skip these statements and you jump out of the loop. You go to statement 5 directly. So iteration statements, as they are known, the loop controls are of 3 types. There are 3 loop controls provided in the C language. One is called while loop, other is called do while loop, and the for loop. These loops we have in the C language. Now let us come back to this statement and put this into a while loop. We have to repeat this statement again and again, but every time we repeat this statement, we change the value of I. We increment it. I equals to I plus 1. We increment it and then multiply, because these numbers are incrementing. First I was 1, second time printf is executed, I is 2, third time it's 3, fourth time it's 4, and so on. So this way we are going to solve a problem. Let us go back to our program. The only thing we are going to change, we are going to keep, is the first printf. Rest we don't need now. What we have changed is this constant to I. Now we are using a variable I. We haven't declared it, so we are going to declare I. So int I. So we have declared it. Right. Now we have to put this printf statement inside a loop, so that we can execute it again and again. So we have a loop called as while loop in the C language. Let's make use of the while loop here. So the syntax is like this: while I is less than or equals to 10, because we have a condition in the loops, right? So let's write this and then we'll try to understand, we'll try to explain, we'll try to infer from this what we have done. Now I, which we have declared, has not been initialized. We have not initialized I. If you can recall from this, the first value of I is 1. So we have to initialize it to 1. The first value of I is 1 and the last value of I is 10. So we have to initialize I to 1. So let's initialize it here. I equals to 1. Right? And then a semicolon, as always, according to the C standard. Now I is 1, and until I is less than or equals to 5, execute this statement again and again. But we are not incrementing the value of I. The next time this printf will be executed, we want the value of I to be 2. So let's put it this way. Firstly, for the first time the control comes here, I's value is 1. Then it checks, is I less than or equals to 10? Yes, it is. It prints num star I. So num star 1. Currently the value is 1. So num star 1. Num into 1 is the number itself, right? So next time it comes into the while loop is executed like this. So next time it comes into the while loop, we want a greater value of I. So we are incrementing I. I is equals to I plus 1. We are incrementing I and storing that incremented value in I itself. So I equals to I plus 1. And we have our multiplication table program ready. Let's run this and check whether it works or not. So we have our application running. Enter the number. We'll input 5. And yes, the program is running perfectly. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So it is running perfectly right. So let's infer from this. First time the value of I was 1, and 1 is less than or equal to 10, of course. Then printed 5. then I was incremented. Now i's value is 2. Now the control goes here again and checks, is I less than equals to 10? Yes, 2 is less than equals to 10. So printf is executed again. Then I is 3, then 4. So this way the number is multiplied with 1, with 2, with 3, with 4 again and again until the condition is true. When I is equals to 10, 10 is less than or equal to, yes, 10 is equal to 10, again printf is executed. When i's value become 11, because the next time it, after printing the 10th multiplication, i's values become 11. So the next time it comes, 11 is not less than or equals to 10, hence the control goes out of the loop here, and naturally the program has come to an end now. Now there is one small suggestion I'd like to give here. Instead of I equals to I plus 1, you can have a short form here, I plus plus. It means the same. I plus plus is increment I and store the increment value in I itself. It means increment the value of I by 1. So plus plus is another operator called as increment operator. There is also a decrement operator available. We will look into it later in this video. Let us now determine the syntax of the while loop. Let us now see the syntax of while loop. What we had was a single while. Right here we had while, then a condition, and then statements. So we had while, and inside this we had conditions. So while condition is true, while the condition is true, we have to execute these statements. Right? There are statements to be repeated. So this way we write the while loop. Now there is another type of loop available in the C language called as a do while loop. Do while loop. And it is, you can say, the brother of while loop. Let's see what a do while loop is. The do while loop is very similar to while loop. There is only one difference. In while loop you have a condition first, and if the condition is true, the loop is executed. In while loop you have to execute the loop at least once and then check the condition. So first the statements are executed and then the condition is checked. So the syntax is like this. We have do and we have statements. We execute statement. First we execute the statements and then we check the condition. While this condition is true, execute these statements. Now do block is executed first, then the condition is checked. Right? And if the condition is true, the control goes back to do and executes the statement again. Let us see an example of the do while loop. As usual, we have the main function. In this we are declaring an integer a, then we are repeating some statements, and the condition is such that if a is not equals to 0. Let's see what we have. Remember that a semicolon is always important after while. There is always a semicolon after while because this statement is ending here and there is no braces to terminate or to end that statement, end that block. So a semicolon is important in a do while loop. Many people make mistakes in that. So coming back to our program, an example, we ask the user to enter 0 to exit and scan that input and put that into A. So if the user does not enter 0, like if he enters 1, so the condition fails. The condition is true. 1 is not equals to 0. It's true. So it executes again the do block. So it comes back again. Let's see some output here. enter 0 to exit, we enter 45. It again says enter 0 because 45 is not equal to 0 is true. So it goes again and says enter 0 to exit. But it executes at least one time. The loop executes at least one time. So when we enter 0, it is the program exits. Now the differences between do while and while loop I've already told is the syntax is such that the condition is first and the statements are later in the while loop. In do while loop, the syntax is such that the statements are first and then the condition is there. While loop executes depending on the condition, and do while loop executes at least once and then the next iteration is governed by the condition. And there is another kind of loop, the for loop, the last kind of loop we have talked of. So the syntax is very similar, very simple. In the for loop, in the while loop you had only condition. You did not have any initialization or increment. You had to do all by yourself. You had to initialize I before the while loop, and in the while loop there was a condition, and inside the while loop you had to increment the counter variable which you say. So the for loop syntax makes very easy to initialize and check the condition and increment all at once. The for loop syntax is like for, and we have the initialized part before the semicolon. In between the semicolons we have the condition, and after the semicolon we have the increment part. And then these statements are executed based on this condition. If this condition is true, these statements are executed again and again until the condition becomes false. So let's take this example which is implemented in the while loop. So we have I equals to 1, while I is less than or equals to 5, print I, and then I++, which is nothing but increment the value of I. So this is initialization, and this is condition. I is less than equals to 5 is condition, and I++ is increment. So we have clubbed this in the for loop. For initialize I equals to 1, then check the condition, is I less than or equals to 5? If yes, print %d I, print the value of I. And then this I++ has gone here in the increment part. So I equals to 1 is initialization, this is condition, and I++ is increment. Now let's look how the for loop runs. We have this loop for I equals to 0, I less than equals to 2, I++, and then we have the printf function. What we are doing in this for loop is just printing the value of I until I becomes 2. So the output should be 0, 1, 2. Okay. So first of all, I is initialized. The second thing is it does is to check the condition. So I is initialized, hence we have the value of I as 0 as initialized. Then it checks condition. Is the condition true? Yes, the condition is true. 0 is less than or equals to 2. So it executes. So it executes the statement, the body of the loop. We have the output 0. Then it increments. So it first initializes, checks condition, executes body, and then initializes. So the current value of I becomes 1. 0 plus 1 is 1. Then it checks the condition. If the condition is true, the body is executed. 1 is less than or equals to 2, the body is executed. And we have the output 1. Now again, I is incremented. So we have the value of I as 2. Then condition 2 is less than or equals to 2, right? The condition is true, hence the body is executed, and we get the output 2 here. So what you can infer from this is that initialization is done only once. It's a rule of thumb. Yes, initialize only once. So it goes like this. Firstly, whenever the loop is executed for the first time, we follow this pattern. Initialization, then condition, then the body, and then increment. So It's like this. When it's executed the second time, when it comes back to execute for the second time, then only condition, body and increment. This is the pattern. And this pattern follows until the loop terminates. Now, what will happen if we write this? For, and we skip the initialization part, we skip the condition, and we skip the incrementation part. It works because this parts can be dropped. It works, and it should be noted that semicolons are necessary here. If you drop the semicolons, then it becomes a syntax error. It's not a for loop then. Now this becomes an infinite loop. There is no condition, there is no initialization, there is no increment. So there is nothing to stop the loop. So the loop goes on executing, executing and executing. Now a common error or what we would say a misunderstanding. If we say for a equals to by any initialization, condition or increment, and sometimes we put a semicolon after the loop. What it does is nothing. It does nothing but waste time. As in the if, we have seen that semicolon becomes the part of the if block. So this semicolon becomes the part of the for block, and semicolon is literally means nothing. So the semicolon is executed again and again and nothing happens. It just wastes its time. Now nesting of loops is allowed. Like you can have if else inside of if else. You also can have for loops or while loops or do while loops inside of loops. And mixing of loops is also allowed. So nesting is allowed. Now let us come back to this program, to our previous program, and modify this thing to a for loop. So we have the initialization, condition and increment already. So let us delete this condition and increment and initialization. We have to put this in the for loop. So we write the for loop for what was the initialization? I equals to 1. And what was the condition? The condition was such that I should be less than or equals to 10, and the increment was I plus plus. You can also write I equals to I plus 1 here. There can be more than one initializations. If you want to have more than one initializations, it's possible here. So this way we have converted our program for loop. Right. Let us run this program and see it works. And if I enter 2 this time, it works indeed. Loops. Now we have seen what are infinite loops. When the condition is always true, the loop goes on executing and executing, and it never stops. So like this is an infinite loop. 1, always signifies truth in the C language. So this is always true. 1 is always true, and printf will be executed on and on and on. The body is executed, and it will always say I will not stop. As this 1 is true. Now loop keeps on executing, and you cannot do anything. The program is going to hang. Now the question is how to stop an infinite loop. So you have to take precautionary measures right in the programming step itself. What you have to do is to use the break statement. We have used break in switch cases, right? We have used breaks in switch cases. Remember, if the control falls down the cases, we use break to move the control directly out of the switch. So this way you can use break to move the control out of the loop. Let's say we have this example. We had this example earlier also in the do while section. So this is also an infinite loop. While 1, so it becomes infinite loop. It prints, enter 0 to stop. It scans your input. You have to enter 0 to stop. So let's put a condition here. If you enter 0, you break. That means you stop the loop. And when it's outside the loop, print that it's outside the loop. This way it is executed. First you enter 0, first you enter 5. So it does not qualify this condition and cannot go to the break statement. It goes on executing and executing until you enter 0. Once you enter 0, you break. And break means break the loop. Do not proceed further iterations. Hence you come out of the loop and print this outside statements. Now the break statement we have just seen is nothing but a jump statement. It jumps the control out of something. It jumps the control. So we have three types of jump statements actually supported by the C language. First is, we have seen, break statement. Another is continue. Continue, like you break a loop, you can also continue a loop. And the third one is goto. Goto is something like go to this spot, go to that spot of the program. It is unconditional and it can take you anywhere, not just loops. It can take the control to any part of the program. Now let us look at continue. Let's say we have a while loop here, while, and there is a condition. And you have a lot of statements. So what we have to do is that we don't want to execute these statements. So what we can do is we can put a continue here. So this way these statements will not be executed. The plan is such that when the control is here while the condition is true, let's assume that this statement will execute it. Once it finds continue, it stops the loop. It goes to the next iteration again. So it goes from here to here. So it will skip the statements below the continue statement. Now there is no point in always directly writing continue. Always use it with a condition. I will later on write some programs which will feature the continue statement. Now for now, remember that how does continue work is whenever the control finds continue, it skips the statements of the remaining statements of the loop and directly goes to the start of the loop. That is, directly goes to the next iteration. It continues the loop by skipping the later statements. Okay, let me write it. What does continue does is continue. It transfers the control to the loop condition actually. It transfers the control to the loop condition. Let us now look at what is goto. Now goto is very simple. Let's assume that you have a lot of statements in your program. Let us write those statements S1, S2, S3, S4, S5. Now what you want to do is you want to skip these three statements S4, S5, S6. You want to skip. And you want to directly jump from S3 to S7. How you can do is use a goto here. You can say that goto. Now go to where? You have to label this spot where you have to go. Let's label this as go to ahead. Ahead label is written like this, ahead and colon. This becomes a label, and we say that go to ahead. So whenever the control goes like this, it executes S1, executes S3, executes S2, and executes S3. Then it encounters go to ahead. Then it searches the whole program where it can find the ahead, the label named ahead. Wherever it finds, it jumps the label, jumps the control to the label, and the label points to S7, so it goes ahead by executing S7, S8. So these statements are executed, these are not. Now, all the computer science programmers or anyone you will encounter in computer science will say this thing: avoid goto. Now, what is the problem with goto is that it is an unconditional jump. It jumps, you can jump anywhere in the program. You can go from here to here. What if you jump here, and from there, from this S7 you jump to some S1, and then again from S2 you jump to some S10, other statements. So this creates a lot of confusion in your mind. You don't know where the control goes and where it comes back. So a natural suggestion would be to avoid goto, and keep this in mind. Always avoid goto. That's it. Now we come to a point where we have to write a program based on loops. Let's write a program. The program is such that, let's consider this series: 1 plus 2 plus 3 plus 4 plus on and on up to n plus n. So you have to take this n from user and calculate the sum of n terms. This is called a linear series, so sum of series. You have to calculate what would be the outcome if we add 1 plus 2 plus 3 plus 4. If n is 10, so 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So up to 10 terms you have to add. Now how you would go about writing this program is, you can first take sum. Let us assume that sum is 0. This sum is 0. Now add 1 to it. First time add 1 to it. The second time add 2 to it. 2 to it. The third time add 3 to it. The fourth time add 4 to it, until you find that I, or the index or the variable which you will use in the condition to control the loop, is equal to n. So this way you can find the sum of series. Let us write a program now. Let us actually take an algorithm and write that algorithm first. Algorithm, by algorithm I mean flowchart. So we start by taking input. Take input n. So take input n. Then let's assume that sum is equal to 0. So put 0 in the variable sum. Right. Then sum is equal. And now we come to a point where we use a loop. Now use a loop here. Now loop is always done in hexadecimals. So this is the construct for our loop. So let's use a while loop. While I is less than n, first I is 1. Right? I is equals to 1. I is equals to 1. Then what we do is we add I to sum. Sum is equals to add I to the previous sum. So previous sum is sum plus I, and then we update the sum. This way the sum is always updated. Sum equals to sum plus I. Then last thing remains is incrementation, I plus plus, and then go back to the loop. Again execute. and when we come out of the loop we do nothing but stop. So let us write a program. So as usual, we have our void main, then we are asking the user to enter the value of n, scanning that user input into the variable integer n. Now we have to declare a couple of integers here. We have to declare in the sum, int sum, and we have to declare I, which will control the variable, control the loop. Now here comes the for loop. Let's implement this in for loops. For I is equals to 1, first time we have to add 1, the next time we have to add 2, next time 3, 4, 5 until we reach n. So I is equals to 1, then we have to run this loop until I is equals to n. So we have to add n also. That is, when I becomes n, we add I and then terminate the loop. So, and the incrementation is such that I is incremented one by one. So in the body of loop we will have sum equals to sum plus I. So this makes our program pretty simple. At last we have to print the sum. Printf the sum is %d, and then what we are doing is printing. We are printing the value of sum, so sum. Right, this way we can easily print out the sum of the series. Let's run this program. So enter the value of n. For simplicity, let's enter 3 now. Oh, we have an error here. What it says that the variable sum is being used without being initialized. Okay, we have committed a little mistake here. We have not initialized the sum, the variable name sum. Remember, we had to initialize sum to 0 first. So let's initialize sum is equals to 0. Now it will work, I think. So let's again enter 3 now, and the sum is 6. So we had 1 plus 2 plus 3. So 1 plus 2 is 3 plus 3 is 6. So we are getting the correct sum. So this is how you write the program which calculates the sum of series in the C language. I think you have got a hang of what loops are, how do you use loops in the C language. What I would recommend is you to practice some programs based on loops, because it's not possible to take all complex programs in these videos, because it makes the videos